Hey there, welcome to this video series where I'll be going over chemistry concepts from Chem 14A that are taught at UCLA. The goal of this video series is to provide short, concise videos that cover concepts throughout week 1 and week 10 of your quarter. In this video in specific, I'll be going over SI units and mass percentage, which are the first two major concepts that you should know in week 1. I'll be uploading more videos in the future that go over week 1 and even more videos that go over the next few weeks. So without further ado, let's go ahead and get started. SI units are just a way that scientists like to measure things. So for example, in the US, we usually like to commonly measure our weight using pounds. We also like to measure distance using miles. And so scientists have devised an entirely different set of units to measure these same types of things. So first, let's talk about weight. Weight in the SI unit system is measured using grams. Right above a gram is the kilogram, I've abbreviated as kg, and right below the gram is the milligram. Obviously, there are more units past the kilogram and the milligram, but when it comes to chemistry, you often won't really be using units outside of these three as much. And so a kilogram is equal to 1,000 grams. Whoa. It is equal to 1,000 grams, or 10 to the 3 grams, and a milligram is 0.001 grams, which is 10 to the negative 3 grams. So whenever you're going up this SI unit ladder of sorts, every rung you go up 3 places. And every rung you go down 3 places. So, for instance, 1 gram is equal to 10 to the 0 grams. So whenever I go up 3 places. 10 to the 0, I go up to 10 to the 3. Whenever I go down 3 places. Sorry, let me write that in a way that it's not crowded. I go down 3 places. It's still a little bit crowded, but I'm sure you understand what I mean. So this up 3 and down 3 system often takes place throughout the SI unit system. So moving ahead, let's go on to distance. Now, the big unit that you use in distance is the meter. After the meter, let me write that a bit over here, is the meter. After the meter comes the kilometer. Right before the meter comes the millimeter. Right before that comes the micrometer, micrometer. And then before that comes the nanometer. So the kilometer, like I mentioned earlier, is 10 to the 3 of a meter. The millimeter is 10 to the negative 3 of a meter. The micrometer is 10 to the negative 6 of a meter. And the nanometer is 10 to the negative 9 of a meter. Now you might be wondering, when will we ever come across something that's as small as a micrometer or as small as a nanometer? Well, in chemistry and Chem 14A in specific, we are going to use the nanometer when we're talking about things such as wavelength, of electromagnetic radiation, and the micrometer comes in handy when you're talking about the diameter of cell sizes. Cool. After those, I want to talk really quickly about the angstrom, which is 10 to the negative 10 of a meter. And why I didn't want to mention it up in this scale right here is because it doesn't fall nicely within that +3, -3 kind of system that I was talking about earlier. The angstrom is kind of its own thing. It's still related to meters, but it's not necessarily within the SI system. And we use the angstrom whenever we're talking. We use the angstrom whenever we are talking about bond lengths between two atoms, or whenever we are talking about atomic radius. So I'll put that right here, atomic radius. Awesome. So that covers distance. Now, after distance, let's talk about time. Time isn't any different in the SI unit system. In the SI units, seconds are often used, and I've abbreviated it here using an S. Awesome. So now, let's go ahead and move on past time, and let's talk about temperature. When it comes to temperature, we often use Celsius when we're talking about temperature. And I'll abbreviate that in parentheses here as C. Now, we also do use Kelvin in chemistry, which is abbreviated using K. But that's more prevalent in thermodynamics and not necessarily in Chem 14A. Another thing to know about temperature is that water boils at 0 degrees Celsius. It freezes at 0 degrees Celsius. And it boils at 100 degrees Celsius. It boils at 100 degrees Celsius. Awesome. The last unit that you want to keep in mind is the mole. And I'll box it in to show that it's really important for you to understand. So whenever I say I have a mole of something, it means it's basically shorthand of saying I have 6.022 times 10 to the 23 of something. Let me use an analogy to talk about the mole. So if you go into a donut shop, you'll often hear someone say, let me get 1 dozen donuts, instead of 12 donuts, even though they automatically mean 12 donuts. Whenever I say I want 1 dozen donuts, that means I want 12 donuts. But we don't say 12 donuts. We almost always use 1 dozen. So in a similar fashion, whenever I want, let's say, 1 mole of donuts, the cashier or the server will say, oh, so you want 6.022 times 10 to the 23 donuts? Now, obviously, that sounds ridiculous, and I clearly do not have the money for it. But we use this magic number, 6.022 times 10 to the 23, whenever we are talking about really small particles, such as atoms. Whenever you have extremely small particles, you're bound to find a lot of them everywhere. And so this number is so special, 6.022 times 10 to the 23, that it's given its own name after the person that figured it out. It's called Avogadro's number. You'll be given this almost always on your formula sheet, but it's a pretty handy number to keep memorized whenever you're talking about it. It's important to note that 1 mole of something is not equal to 1 molecule of something. It's very important to understand the difference between a mole and a molecule. A molecule is just a way of saying a compound, a mixture, actually not a mixture, a compound of 2 separate elements. A mole, on the other hand, is just a way of saying, similar to a dozen, that I want 6.022 times 10 to the 23 of something. So now, let's talk about mass percentage. When someone asks about mass percentage, they're basically wanting to figure out how much does one element make up, in terms of percentage, obviously, of the total mass of a molecule. So that sounded a little bit complicated, but once we go over an example, I'm sure it'll be a lot easier to understand. So let's take the example of a simple molecule like CH4. Common question that you'll get is, what is the mass percentage of carbon in CH4? So the way we'll figure that out is by figuring out any percentage. And the way we figure out a percentage is dividing the total of whatever we want to find divided by the total mass of what that something is in. So in other ways of saying it, we want to do the total mass of carbon and divide it by the total mass of CH4. So let's go ahead and do that. So first we want to figure out the total mass of CH4. 1 mole of CH4 is made up of 1 mole of carbon plus 4 moles of hydrogen, because there are 4 hydrogens attached as well. And if you look at your periodic table, 1 mole of carbon is 12 grams plus, now 1 mole of hydrogen is 1 gram, but since we have 4 of them, we need to multiply 1 times 4 to get the total amount. So that gives us 4 times 1, and so therefore, in total, 1 mole of CH4 is 12 plus 4, 16 grams. Perfect. So now we figured out 1/2 of our problem. We figured out the total mass of CH4. Now we want to figure out what is the mass of carbon in this molecule. Well, that's pretty straightforward. We've already calculated that the mass of carbon is 12 grams. So what we need to do to find the mass percent of carbon in CH4 is we need to do 12 grams, divide that by the total mass of CH4, which we figured out to be 16 grams, and that will get you 75% carbon. So CH4 is 75% carbon. Now, if someone asked a different question, what is the mass percentage of hydrogen in CH4? What we would do instead is same process, except instead of 12, we would do 4 grams of hydrogen, because in total we calculated that since there are 4 moles of hydrogen, 4 moles of hydrogen weighs 4 grams. So we have 4 grams, divide that by the total mass of CH4, and that gets you 25% hydrogen. And it makes sense that CH4 is made up of 75% carbon and the other quarter of CH4 is hydrogen, because when you add these two together, you get 100%. Now what this means is that CH4 is 100% made up of carbon and hydrogen, which does make sense because CH4 is 1 mole carbon, 4 moles hydrogen. So that's just an example of mass percentage, and that wraps up this video. I hope you enjoyed it, and in the next video I'll be talking about dimensional analysis and limiting reactant.